So now we're going to look at some functions and some domain, range, and continuity of these functions. And we'll start with a few definitions and look at some examples to see if we can make some sense out of this. To begin with, we got some definitions here for domain. Domain is the set of all possible x values, or the inputs in a function, and the range is a set of all possible y values in a function. And so here we have a quick example. We have a function that we want to find the domain and range for here. So here's our function, y equals the square root of x minus 10. And our domain, what we want to think about is we want to see if there's any restrictions is the key. And to find our restrictions, we want to think about what's underneath the radical here. So that's what we want to think about to start with in this case. And so we think about what kind of numbers are limited for radicals. Well, we want this number underneath to be 0 or greater, because if we put a negative number in the radical, then we have an irrational number. And this is a function on the real numbers. So we want x minus 10 to be greater than or equal to 0. It's okay to have 0 under radical, that's fine. And solving this, adding 10 to both sides, we have x is greater than or equal to 10. So there is our restrictions for possible x values. Again, x values are the domain here. So we can now state our domain as a set. We could use set builder notation, we could use interval notation, and in this case we'll go ahead and prefer to use interval notation, and since we're talking about the real numbers. And so we're going to go from 10 to infinity. The range now, the range is all the outputs. So to find the range, we can think about these two domain values here. And if we put 10 into here, let's think about what we get for a y value. What is our output? Well, when we put 10 into x here, then we get 0. Y is 0. All right. Well, what happens as we approach infinity, as we get larger numbers? Well, let's pick a larger number, maybe 20. So if we plug 20 in here, we get 20 minus 10. 20 minus 10 is 10. And the square root of 10 would be a positive number, larger than 0. So it's increasing. And so we know that the minimum y value is 0. And then the y value is just going to increase and increase and look like this. We can confirm this by looking at a graph. And when we graph this, we're going to have something like this. Here's our x and y axis. And then over here at 10, when x is 10, y is 0, and on graphing it, we're going to get a curve that looks like this at 10. So we have, when we're finding our domain, we have a couple restrictions to watch out for. So just to summarize those couple situations that will arise. If we have a radical, we want to make sure that this number, which by the way is called the radicand, we want to make sure that the radicand is greater than or equal to 0. So setting that equal to 0, that will tell us what our x values have to be, just like we did in the problem a few moments ago. And one more situation here, when we have a denominator, a variable in the denominator. Well, we have restrictions on the denominator here. We need to know that the denominator does not equal 0. All right. So in this case, we don't want 2 minus x to be equal to 0. And we have a simple equation to solve. We can add x to both sides. X equals 2. Okay, so that is our restriction. We could also say if we want this does not equal, that's our restriction. So we have all real numbers such that x does not equal 2. So how do we list that as a domain? The domain of this function, well, it's anything except for 2. So on a graph, a number line, if this is 2, we can have, I'm going to put an open dot there, we can have all of these numbers off to the right are okay. All these numbers to the left are okay. So we can write that in this way. We have all the numbers from negative infinity up to 2. 2 is not included. Then we have a break, and then all the numbers from 2 to infinity. And we're going to stick those together with a union. And what numbers can we get? Well, the range, that's a little different situation here. We've got to think about that carefully for this. So we have 2 minus x, all right? And there's a cutoff at 2. Well, let's think about both of these here. When we plug in 2, well, that's undefined. When we plug in a number larger than 2, we get 3. So if we have, or let's think of a number real close to 2 here. Okay, so if we've got a number real close to 2, then, for example, 2.1. Let's go ahead and erase this here. So if we plug in 2.1, we're going to have 1 over 2 minus 2.1, which is 1 over negative 0.1. Okay. And well, this is going to be a negative number. The absolute value is going to be pretty large. This is 1/10, and so this will actually be negative 10 because that's the reciprocal of that. And if we pick a number even smaller than this, and you can try it out, we'll get even a larger number. So it's going to be a real small negative number, or we could say it's large in absolute value. So if this is going to be 2.0001, then this is going to be negative 1,000. All right. So this is going to be a big negative number, or large in absolute value. Okay. And so we can get numbers all the way down there. Okay. And then we can see if we plug in a positive, or just below 2, so somewhere over here. If we plug in a number like that, like 1.9, well, we have 1 over 2 minus 1.9. And that's going to give us 1 over 0.1, which is 10. Again, if we plug in a number like 1.009, this will be real small, 0.0001, and this would be a number like 1,000. So we can get huge numbers and we can get small numbers. All right? And so the one number that we can't get is in between here. So what happens as this gets infinitely large? We got to think about that real quickly. Well, as we get a huge number in here, that's the case. So as we go to infinity, when we plug in a large number here, we're going to have 1 over a large number. Okay? So we're going to have 2 minus, let's say, 1,000,002, okay? Or if we go to the negative, we're going to have 2 minus negative 1,000,002, okay? So either way, we're going to have 2 or 1 over a big number, okay? So 1 over a big number we know goes to 0. All right, and so our range, when x is getting out to infinity, our y value is going to 0. Okay, so 0, we'll never touch it, but we'll get real close. All right, so what that tells us for our range is that we'll have this. We'll have from negative infinity to 0, and we have 0 to infinity. Okay, all right, and we can see that on a graph. If we graph this, we'll get something like this. If we graph it, we'll have something like this. We're going to have some asymptotes at 2, and we're going to go like this. We're never going to touch this, and here's an asymptote. We'll never touch the x-axis, but it's going to look like this. Okay, and there we have it.